Namaskar and welcome to Pustakalya Wala Podcast episode 5. And today we are going to discuss the methodological requirements to get the data, to get the evidence for the theory of electromagnetic field for consciousness, right? Um, and I've been reading Susan Pockett's book and trying to understand this practical aspect of science, and I am amazed and I am scared and I am in awe since I read the type of things that you have to worry about in order to get a valid evidence in any experimentation of any kind, I guess. For example, first of all, methodological requirements for this whole field, you need, first of all, the thing that she has discussed are EEG and MEG, these two methods through which we can understand electromagnetic field data and gather electromagnetic field data. EEG is electroencephalographic studies and MEG is magnetoencephalographic. They have this property that they're highly precise time wise. Like you can actually really understand what exact moment. They have millisecond precision on when exactly the brain waves, brain patterns changed, but they have really low spatial precision. It's hard to know which part of the brain generated that wave or signal. That's one problem with this data. It's not very precise, and we don't have technology yet to get very precise data. I think functional MRI is something that has come up very, if I'm not mistaken, because this book is 20 years old and functional MRI is not that old, I think. So this might be different now. But still we can understand the pitfalls and problems that occur in getting the data, and this is highly. I'm in awe. My respect towards experimental scientists has increased so much, because this is just a hellhole. Elimination of artifacts, the first problem. There are a lot of artifacts because nothing is precise. We are living in a real world. Things happen. Let's, for example, muscle activity of the scalp or the eye muscle can contaminate the recordings, right? They are everything. All the muscles are running on electromagnetic signals, electronic signals, electrical signals, whatever you might call it. The second one is lateral eye movement and blinks, which are actually part of some cognitive processes. Have you noticed when you remember something, when you try to remember something from your past, you kind of look towards your side up there? That's part of the way the mind works, right? The eyes work like that. In REM sleep, the word REM is rapid eye movement. Eye movement is a big part of cognitive processes. They have to be handled separately because that will ruin the data. Then there is problems with coherence measurements. Coherence measurements are, we are trying to figure out if because in case of consciousness, because everything has to be globally in one workspace, coherence is a way to understand if different parts of the brain are in coherence with each other. If they are in phase, they stay in phase. If they are out of phase, they stay out of phase. That's being coherent. So that's that's one experiment that they try to do. These are all methodologies, what all are possible to do, right? The way EEG works has some other pitfalls. There is one. The way EEG works is it has one recording electrode and the other reference electrode, and it's kind of like a control electrode, and things are subtracted from each other and figured out what happens. So reference electrode is the baseline of your body which is always present. So it has to be on the body reference, so that our heart is also creating some electrical signals. They need to be removed from the recordings. So you cannot keep them out of the body. It has to be on the body, and when it is on the body, it's also susceptible to problems, because if you put it on the ear, that will be affected. The brain waves will also affect that electrode. It's not a complete separation, so there is more lack of precision over there. Some people have adopted this idea of average reference. Instead of using a reference electrode, you just average out a lot of different data from different electrodes and use that as a reference electrode. There are some ways in which Laplacian derivatives she talks about. I have no idea what this is, but there's something related to that. And then she says these are all a part of science, and life is never simple. These are her words. And I should tell you, we feel you, Susan. We feel you. Life is never simple. And I'm amazed. It's so hard to know things. I am reminded of Richard Feynman's quote on this. People think it's easy to know things. Okay, this eating an apple a day does this, and broccoli is good for you. And I'm not saying all of these are wrong, but it's the system that we are talking about, the gastrointestinal system, is so complex that it's hard to know anything for truth, and that's why we don't know what is good nutrition. We can differentiate between bad food and good food to some extent, but not very well, right? And this is the reason life is never simple. And another problem that can come up with is overusing the frequency filters, because you want to get only some frequencies. You put filters, but those filters remove some other things and whatnot, and blah blah blah, something like that. I'm not really sure at this point. Then you have to control for general physiological factors like your age, your height, your level of arousal, your all those different things. That is, you have to take care of. And then one of the biggest problems is isolation of consciousness from the rest of the processes, because there are a lot of pre-conscious processes that happen, pre-conscious events that you go through before doing something conscious. Before I decide to pick up this glass, my mind made some pre-conscious processes. Before it came to that level of conscious experience, it went through a lot of pre-conscious processes. And how do you manage to, and that also creates its own electromagnetic waves, right? And how do you separate those two? One way to counter that is to have two closely related pairs of cognitive states. One is conscious, the other one is non-conscious. I don't know any examples. She didn't give any examples. And differentiate between them. Difference between the data would kind of give you some understanding of what the conscious process brought on the table. But this is highly criticized by some people. Friston in 1996 criticized this actually subtracting the two data from each other and then getting the data. It's not really a valid way to get data. The methodology of experiment might require the person who's setting the subject to press a button in order to communicate with the user, communicate with the scientist about their internal conscious state, which is what we are trying to study. So the communication channel, whatever that might be, pressing a button, looking at something, saying a sound, or whatever that be, creates its own EM waves, creates its own signals, and that will corrupt the data. There is one very interesting solution to repeat the experiment with a different mode of communication. The first time, if you used pressing a button, next time use making a sound, or the third time use looking at something and blinking or whatever. And even then it might not eliminate certain generalized motor readiness potentials. I think we have these when we are ready for movement, that itself creates some potentials, electric potentials. Just the fact that the person has to be ready to communicate at what exact time, what happened in their conscious mind, that very, no matter how you communicate, the very fact that you have to communicate is going to mess up the data. And then she goes on to attention and memory, and this is what we'll cover tomorrow, because attention and memory can affect the way in which data can occur. And the final word on this topic is just sheer amazement in the fact that I am not the one to be doing it. Or maybe it would be interesting as an engineering problem to get data. Maybe that's how they figure it out. Maybe that's how the experimental physicists or experimental psychologists or whoever is doing this experiment looks at this problem as an engineering problem, and maybe they get some fulfillment out of these small increments. But this can be really sorry to say this, but this can be really disheartening. There's the fact that we have this theory and we want to test it in so many different ways, but our equipment is primitive. It's spatially not precise. It's there are so many pitfalls. But this is what I guess. This is what it takes to know the truth. This is what it takes. This is the kind of resolve you need to know the truth. It's very easy to just sit and say, "Oh, consciousness is creation of the EM waves," and when there is with one big consciousness, become Deepak Chopra. Anyone can become Deepak Chopra very easily. Nothing against that fellow. I've heard some good things about him also. That he's a nice fellow. He's not a villain. We are not trying to make him a villain, but you know what I'm talking about. Just fluff. Just this fluff is easy to do, but actual science is so hard. And this is my way of kind of understand what it takes to be correct in a field and be a little more humble. See you tomorrow. Talk to you tomorrow with some new interesting things.